My name is G. Brooks Stack. I'm one of the co-founders of I4.0 Automation, and we're a control systems integrator based in Fresno, California. We are focusing on software integration on the PLC and HMI side, motion control, etc. So actually working on equipment, making it move, things like that. So I'm going to talk about legacy equipment and what that means to me, and then how we got some data for a case study. So legacy equipment, first off, probably people are thinking installed decades ago, very old at this point, maybe doesn't even have a control system. Maybe it's equipment that's just completely manual, still has relays, or just has a very simple control system. It might even be equipment that very few people know how to use or even like operate. You want to learn something about it and you want to pass on that information so that people can make that equipment continue to run for a manufacturing operation. It also might be extremely custom for your manufacturing operations. Maybe you have equipment that only works for your process and it was built for you. You can't just go easily buy that thing and it's hard to replace. Or it might be equipment that you bought recently, but there wasn't actually Industry 4.0 or those types of things thought about, and you want to start to get data out of it. In summary, what legacy equipment means to me is that there is no data to get through electronics, or it's all inside a machine and it's kind of just like an island. If you wanted to enable Industry 4.0, there's a few options that I can think of. One is just that you could just completely get rid of the equipment and replace it with something that has that. But obviously that is a very expensive option, and maybe you can't do that because it is completely custom. You could replace the control system or upgrade it. It requires a lot of planning to do that. And you have to be able to have the know-how in-house to be able to make that successful. An easy way that you can start to get data from machines or communicate to machines is that what I would just say, in general, try to connect to it. You need to know how to communicate to that equipment, understand industrial protocols, but usually you can add some type of communication and then actually be able to pull data out while you plan to maybe replace it or migrate and upgrade. I'm going to talk a little bit about a case study that we did that was on this connect side, this parallel getting data out of the machine. This is a customer that had a global presence. They had multiple facilities in the US, and all of their machines were custom built to their process. So it was very specific, and they had specific control systems for them, but they were all kind of like legacy in that type of thing. Like no one really knew how much about it, and they all had only serial Modbus communication. So now modern control systems have some type of Ethernet base, OPC UA. You can't just like connect all of our modern tools directly to this controller. Some of the reasons that they wanted to connect to their machines is that these were very large facilities. They had a bunch of these machines and they couldn't really tell when their equipment was down. They didn't know if they should go walk over there and see if it was still running, if they were still producing. They also wanted to get data to be able to benchmark their throughput, be able to keep the rates up. Again, they weren't able to go see what they actually made. They're just running for a certain shift. And then they also wanted to be able to refill the material, again, with being able to know when the equipment is down. Similarly, should they refill the machine? Where should they put their maintenance crew, etc. At the time, actually, that was MindSphere. It is now Insights Hub. But the idea was that we took an IoT 2050, which is a single board computer, basically like an industrial Raspberry Pi. It has Node-RED inside of it. You can create custom programs in order to take the data from a machine and then push it to MindSphere Insights Hub to the cloud. What we did was we worked with the customer to define a standard data set which was common on all these machines. Again, there was the same machine over and over, but there was some differences between them. So they had a standard set of data, like their product type, if it was running or not, if there was a fluid leak. So if there was a fluid leak, they would want to go talk to the machine. And then we had that standard set in the IoT 2050. We pushed that to Insights Hub. And the other thing that was kind of cool about that is that we were able to create, because of Node-RED, a custom dashboard where they could connect to each one of these machines. And if there was a slight difference between these machines, they could enable it with that dashboard, and then it would start pushing to the cloud at that time. So that was what we did, and I think it was pretty successful for them. It ended up being a pretty quick setup for them in the end, and then they could just take one of these boxes, pop it in the machine, and then it would start pushing to the cloud. Did you have any thoughts on what you would do with Mendex versus this?
Yeah, definitely. So first thought maybe is that with our industrial edge infrastructure, we can easily manage those devices also including the IP 2050 at scale, right? So one layer above, we have a management system which allows you to, first of all, manage all the devices, but then also applications like Node-RED over different plants, centrally and globally. So that's one cool thing. And of course, you can also run other applications on that device instead of Node-RED, like Linux applications maybe. So that's cool.
Maybe on premise.
Exactly, on premise, not only gateway use cases, of course, right? So also value-adding applications.
Yeah, that I think that's one of the things to consider here with any of these applications is if you're completely making a custom software for it, it might be a larger development upfront. You kind of have to think of the scale. One of the things with the IoT 2050 is that it really is just a Linux computer, right? And like you can put anything on it. There was other products at the time that you could consider. I think the 2040, that was a standard solution that got phased out. I think that in this particular case, it was only a very small investment and a small scope, so it made sense. But if you're thinking about huge scale, maybe that investment does not.
I think what you've shown is one step on the way to digital transformation, right? First of all, understanding that you have the data is important, understanding that you can leverage that data and come to the cloud, which is something over there. And I think that's a one-way street, yeah, but as you said, it's probably a low investment. It can be quickly done with no bread, so that's ideal. Yeah? And later on, you can definitely extend that, maybe like, as you said, as Nico said, industrial edge, maybe bring in more applications and also play it back, close the loop and play it back to the automation layer to change also something, right? In the end, it's different sizes of how you want to play the scale, right? And as you've seen in the videos that you showed earlier, and I think that makes it very, very good. Yeah? This is the reality for our customers. They have a brownfield setup with existing machines. They're not going to throw those machines out. They're not heavily investing in hundreds of devices. Yeah? And this is one way to get the data out quickly and harness the value that the data they create.
Yeah, I actually have a few different slides that past this that do address that. So one of the things that I was thinking about is like if you wanted to do this or you have these legacy machines, it's like why are you doing it? Like what is the value and is like the expectations that you're setting, right? What I thought what you were saying was made a lot of sense is like, yes, you can just read this little chunk and you want to show that value. And then like, what's the next step? What's the next step, right? I think even if you've never even attempted this, what expectation do you have? Like the reason why I thought this was like a good depiction is like, you're not going to be like all of a sudden like doing AI, right? But like you want to put that road pathway to get there. I also have a bunch of stuff on the technical feasibility of that. But one of the things that I thought what you were saying with the starting to write to the machines, right, is like now you're thinking about cybersecurity. Like if you're actually starting to change things on the machine, what is involved there? Like can that equipment actually move and could you destroy equipment, things like that? You have to start to plan in a different way when it's one way versus two way. Any other thoughts on that?
Maybe one more thing about the computation and how we got there. I think you had the example of Decibel, like literally how loud the machine is. And
Yeah.
I can show you if the machine has an issue or not. Yeah, that data is enough for you to determine it's already an issue. That's great, right? But let's say you are working with 5-axis controllers and so on, and they create a lot of data. Yeah. Then it might make sense to not pump it also somewhere else. Cybersecurity certainly is an issue. Yeah. If you want to pump something to the cloud, you have to take care of it, especially in the red. If you want to play it back to the factory, it really depends on the use case and on the industry you're in.
Yeah, that was one thing that for anything with a motion controller, right? Like now you're talking about maybe like milliseconds of time, right? Like is it once per day you're trying to collect this data, or is it like you need to actually see like the torque of a motor, which is a completely different time scale and amount of data that you're taking in. Thank you for your feedback. Appreciate that. Cool. All right. Well, thank you very much. Thanks for talking with me.